to a video on fractions and decimals. And we know fractions are decimals. So if you're at a deli, let's say you're at an Italian deli, we have the pastrami and the provolone all hanging. Okay, so at the deli you order, let's say, a quarter pound. You order a quarter pound of roast beef, whatever it is. So on the scale, right, the butcher or the deli clerk, by the way, there's a fly on that roast beef. Don't buy that roast beef. So on the digital meat scale, it's going to show it in decimals. So you order a quarter pound, we know that's 0.25. And how do we know it's 0.25? We convert it, right? So the first number, the top number, we know always goes in the box. We just drop it down. Always the top number. We know 4 doesn't go into 1, so we have to put a decimal. Dot, 0, extend. Remember that? Since 5th grade. So 4 goes into 10 twice. And we're just doing division now. And 4 goes into 25, so we have 0.25. So we know that if you order a quarter pound of roast beef, and we're not getting this roast beef, not with that fly there, but if we did get good roast beef, the deli clerk would have it as 0.25. We say 1/4 pound, he's giving us that. That's why fractions are decimals. Okay, so let's say you go to the Italian deli and you want some prosciutto. You want prosciutto di Parma, the best prosciutto you can buy. So you want a 3/4 of a pound. 3/4 of a pound. How would you make that a decimal? Di Parma, right? Fix that I to I. Di Parma, from Parma, Italy. So how would you make that a decimal? So here's 3/4. What goes in the box? The top number. 4 doesn't go in the 3. Dot, 0, extend. So what'd you get? 4 goes in the 30 how many times? Oh, good, 7 times. Bring down the 0, and we get 0.75. So that's what the digital scale will read. Now, as you notice, the decimal terminates. It ends. 0.75. It terminates. It ends. So that's, and we went over those in 6th grade, terminating decimals. Let's try another one. Make that a decimal. 2/5. What goes in the box? The 2, right. Top number always goes in the box. Okay, so the numerator goes in the box. And 5 doesn't go in the 2, so we put dot, 0, extend, and 5 goes into 20 4 times, so 0.4. 2/5 is also 0.4. And we know that 2/5 also is 4/10. They're equivalent. So integers, fractions, and decimals, they're rational numbers. And there's the symbol Q. So the fraction, let's say we have two numbers, A over B. Some people use P over Q, and we went over this. And as long as B or Q, whatever the numbers you're using, is not 0, we can never have a number like that. That's undefined. It's undefined. Can't have a 0 in the denominator. But you can have a 0 in the numerator. So where is my eraser? All right, so you can have this, no good, but you can have that. Okay? So decimals, fractions, integers are all rational numbers. However, as we said, the fraction can't have a 0. And the decimals have to do two things. So the decimals have to terminate, which we say are end. They have to end, or they have to repeat with a pattern. Let's fix that so we see it. They have to terminate, and again, terminate means to end, like 0.75 we did before, and 0.25, they terminate, they end. Or they have to repeat with a pattern. There has to be a pattern. So if I had like 3.23, and it continued 2, 3, 2, 3, 2, 3, 2, 3 forever, that's the pattern. Put a line over it. 2, 3 repeats with a pattern. If it doesn't repeat with a pattern, and it doesn't terminate, they're irrational numbers. And we know that pi is one of the most famous irrational numbers. Pi doesn't end. It's 3.14, 15, 92, 60. It keeps going. And there's no pattern to it, as far as we know. There's a computer in Japan. I think it's in the quadrillionth place right now, and they still haven't found the answer to that. So we know pi is irrational because it has no pattern. But if there is a pattern, like 0.33333, that's a pattern, right? You can just say 0.3 with a line. It repeats with a pattern. So those are rational numbers. Okay, so let's look at 5/12. Sometimes you can see a fraction like that, 5/12. We saw that in 6th grade. You can see it like that. So, what's that decimal? Bring it down here. What goes in the box? The numerator. Great. Dot 0 extend, because 12 doesn't go into 5. So what did you get? Okay, so 12 goes into 54 times. That's 48. Bring down the 2. 12 doesn't go into 20. It goes in once. Bring down the 12. Now, bring it up more. 12 goes into 80. How many times? Okay, it goes in 6 times. And that 6 is going to repeat. Now it's 4.416 repeating. Good. So again, remember, the top number goes in the box, the numerator in the box, and then just divide. Now, here's a decimal. How do we make that a fraction? Just look at the place. It's in the 10th. 3/10. Simple as that. Right? Try this one. Now we're going to have a mixed number. It's 3, what do you think? And 2/10. And it could be reduced. Put it in lowest terms. Okay? What about this? What's that decimal? 0.45. What's the fraction? 45 hundredths. Just check the place value. Okay, let's order from least to greatest. Now we have a mixture of decimals and fractions. So which one is the least? Which one's the greatest? Well, first, let's find out what 2 3/5 are. What is 2 3/5? Bring the 3 down, remember? 5 goes into 30. 6 times. So this is 2.6. We know that's the greatest number. Now, which one's the greatest over these two? This one. So they're already in the order from least to greatest. Right? They both have a 2. They all have 2s. This has a 4. This has a 4. That had a 6. So this is the biggest number. And of course, they both have zeros, even though that 0 is invisible. This has a 1. That has another 0. So this is in order from least to greatest. Now let's compare. I'm going to use some letters here. It's going to look a little confusing. Let's say that this M, this letter M, has to be greater than 1. So you can make M any number you want. It has to be greater than 1. It could be 1.2. Could be 2. What if it's 2? Well, what's 2 over 2? Is 2 over 2 greater than 1 over 2? Well, 2 over 2, you know that any number over itself is 1. And 1 is greater than half. So you could have made this any number. It would still be 1. If you made it 1.96, then this has to be 1.96. And it'll be 1.